All right, let's jump right in. Today, we're taking a close look at a course that is absolutely essential for modern brain science, computing for neuroimagers. We're going to break down exactly how this course promises to take that messy, chaotic data you get from a scanner and turn it into clear, powerful insights.
Okay, so let's set the scene. Imagine you're a researcher. You've done it. You've spent weeks, maybe even months, collecting all of these beautiful, high-resolution brain scans. The data's finally yours, sitting right there on your computer. It's this incredible moment, but it's almost immediately followed by this giant, kind of scary question. Okay, now what? Because let's be real, modern neuroimaging doesn't just give you a little bit of data. It creates an absolute avalanche of it. It's huge, it's complicated, and honestly, it can be totally overwhelming. This course is designed to do more than just help you survive that avalanche. It's going to teach you how to actually surf it.
So let's start by framing the core problem here, what we're calling the modern brain data challenge. We're going to see why these specific computing skills aren't just nice to have anymore. They are completely non-negotiable in today's research world. Before you can analyze anything, you need a system. Without one, all that valuable data is like a library where someone's just thrown all the books on the floor in a giant pile. The solution is something called BIDS, the Brain Imaging Data Structure. And this is so much more than just making your folders look tidy. Think of it like a universal language for neuroscience. It's a standard that lets labs all over the world share and reproduce each other's work, which, as you know, is the absolute foundation of good science.
And your guide on this whole journey? That's Dr. Diane Patterson. And her story is pretty amazing. She actually started her career imaging the vocal tract of Alex the parrot. Yeah, the famous one. Before she ever got into human fMRI and diffusion MRI. It just goes to show you're being led by a true expert who's driven by this deep, genuine curiosity. Exactly the kind of person you want to learn from.
Okay, so we've laid out the challenge. Now let's get to the good stuff, the solution. This next part is all about the tools and the workflow you're going to master. Basically, we're building your professional toolkit for a career in modern neuroscience.
Now, the course syllabus has about 10 different topics, but it really all boils down to this super elegant 4-step workflow. First, you organize all that messy raw data using the BIDS standard we just talked about. Then you process it, and you do it at a massive scale using high-performance computing. Next, you automate all the really important stuff like pre-processing and quality checks. And finally, you get to do the fun part. You analyze that clean, organized data to find those incredible insights. It's a really clear path from total chaos to real clarity.
And here are the actual, specific, in-demand tools you'll get your hands dirty with. Think of it like a production line for scientific discovery. You'll use something like MRI-QC for quality control. It's kind of like a spell checker for your brain scans. Then you'll use these incredibly powerful automated pipelines like fMRI prep that handle all the complex prep work, literally saving you hundreds of hours. This isn't just a random list of software. It's the exact toolkit that the best labs are looking for right now.
And you learn all of this in a really focused 7.5-week sprint. The schedule is designed so that everything builds logically. You start with the absolute foundation, which is BIDS. Then you ramp up to the serious power of high-performance computing. By the middle of the course, you run in quality control, and then those final weeks are this fantastic deep dive into the nitty-gritty of fMRI and dMRI processing and analysis. Learning about a bunch of tools is one thing, but really being competent, well, that comes from actually using them, right? So how does this course make that leap from just knowing about something to actually being able to do it? It's all about putting that knowledge into practice.
And that brings us to the final project. Now listen, the goal here isn't just to check a box and finish an assignment. The goal is to turn you into a self-reliant problem solver. To become that person in the lab who can be given a new challenge, a new data set, and can confidently figure out the right tool for the job. That ability to evaluate, document, and make smart decisions, that's what makes a researcher absolutely invaluable.
And the project itself is broken down into 2 really clear, manageable parts. First, there's a simple 1- or 2-page proposal where you just map out what you want to dig into. And second, there's the final project document, which is basically a detailed report on your journey, what you tried, what worked, what didn't, and what you learned along the way. It's a very structured and supportive approach.
The course also does something really smart. It tailors the project expectations depending on where you are in your academic journey. For undergrads, the main focus is on mastering a new piece of software and just reporting on that process. For grad students, the bar is a bit higher. You're expected to do more independent investigation and actually apply these tools to real research data, either your own or from a public database. So, what about grades?
Well, the philosophy here is pretty clear. A massive 86% of your grade comes directly from the weekly modules. This isn't a course about cramming for one big exam. It's about rewarding you for consistent, step-by-step learning week after week. The final project and the class discussions just round things out, making sure your deep dive and your work with your peers are valued too.
All right, let's bring this all home. You've gone through the modules, you've mastered the tools, you've aced the project. So what's the end result? What's the big picture? Well, it's about making that transformation from being a student to being a truly capable, confident neuroimager.
And what you walk away with are real, tangible skills, not just abstract theory. You'll leave knowing exactly how to take that raw data from the scanner and see it all the way through to the final analysis. That means converting it to bids, running it on a high-performance computer, and using automated apps for quality control and pre-processing. Put simply, you will master the entire modern workflow, from start to finish.
And really, at the end of the day, this course isn't just about teaching you about neuroimaging. It's about shaping you into a researcher who can walk into any lab on day one and make a real meaningful contribution. It's all about being ready to have an immediate scientific impact.
Which, really just leaves us with one last question. When you have the power to take that data chaos and turn it into clear, beautiful insight, are you ready to get to work and help build the future of neuroscience?